Welcome to a lesson on trigonometry. The tri part of trigonometry stands for triangles, and then the rest of the word refers to measurement. So if we can read the word in reverse, it's basically saying that we are measuring triangles. Okay, and there's a specific type of triangle that we work with. It's only right angle triangles, which means it's equal to, has an angle of 90 degrees. So opposite the theta angle is your opposite side, and then opposite your 90-degree angle, it's your hypotenuse. And what's left will be your adjacent side. We'll have to use this for the ratios sine, cos, and tan. Now there's also a formula that you are familiar with. I'll show you soon. Right. So sine, cos, and then tan. So there's three ratios that we are going to use. Okay, so sine is opposite over hypotenuse, and then cos is adjacent over hypotenuse, and then tan is opposite over adjacent. Right, so a way to remember this is so, ka, toa. So we can use those type of ratios, these types of names rather, to remember the ratios. Okay, so let's use this, the information that we've just learned in this problem there that we have here. Okay, so we remember we have our 90-degree angle, which means this is a right angle triangle, and then we want to calculate the length of DF. Okay, so we determine our side, so we want to calculate the length of that side there. So then we determine our side. So opposite, we're going to use the theta angle here. So opposite theta is DE, which is our opposite side, and then opposite our 90-degree angle is DF, which is our hypotenuse, and what's left is our adjacent side. Yeah, there we go. So when we see these type of opposite, hypotenuse, adjacent, we think about this formula: h squared equals to o squared plus a squared. What formula is this? It's the Pythagorean theorem. There we go. I said earlier you'd be familiar with the formula that we're going to use. So Pythagorean theorem. So let's substitute. Okay. Hypotenuse is DF, which is our unknown in this case, what we want to calculate. And then our opposite is 5 centimeters squared. And then our adjacent is 12 centimeters squared. Right. Our DF squared equals to 5 times 5 is 25 centimeters to the power of 2 plus 144, that's 12 times 12 centimeters squared. Don't forget the squares, people. Very, very important. DF squared equals to, if you add the two values, it gives you 169 centimeters squared. So to get rid of the square, we square root, and therefore DF equals to 13. So now we generally say plus minus 13 centimeters, but in this case we just conclude here with 13. Okay, now you get questions with regard to the ratios that we've just used. So we need to get the value of sine theta, cos theta, and then tan theta. It's not theta, people, it's theta, th. Okay, opposite over hypotenuse, we remember this from so, right, which is the opposite over hypotenuse, and then our sine theta value is equal to, so we can see our opposite, which is 5, so it's going to be 5 over our hypotenuse, 13 centimeters. There we go. Right, let's go to the cos. Cos is ka, so adjacent over hypotenuse. There we go. And so our adjacent side is 12 centimeters over 13 centimeters. There we go. And so that's our cos theta value. Now we go to our last one, which is TOA. And then O is for opposite, and our A is for adjacent. And therefore it will be 5 tan theta equals to 5 centimeters over 12 centimeters. And there we go. And so that's how you basically remember it. SOCA, TOA, and then you will never get the ratios wrong again. Okay. So the following one, and post your answer in the comments. Right. So you basically going to try this one. And then post your answer in the comments. But these are the questions that goes with this figure here. Determine the length of BE, right? That's your side that you need to calculate. And after calculating the side, determine, so we're going to put theta by angle N, and therefore you must determine all the ratios for me as well. So when you have your answers, you post it in your question, in the comments. So I'm going to number the questions for you so that you can basically just write it properly. Right, so you can answer all those questions, and then this will be good practice, right? And let's try the next one. Okay, so we have angle beta, we have angle alpha as well. So you can use either one as your angle of origin, but in this case I will use angle beta, right? So opposite angle beta that's my opposite side, and then opposite the 90 degree is my hypotenuse, and what's left is my adjacent there by 7. Okay, so the question here would be, for example, determine the length of E, right? Side E. Or it could be the length of DF. It could be either way, right? They can state the question either way. So we're going to use h squared equals to O squared plus A squared. What formula is this, people? Pythagoras theorem. Right. So our h we don't know, and then our opposite is 5 to the power of 2, and then our adjacent is 7 to the power of 2. So E squared equals to 25 plus 49, and then E squared equals to 74. And so now we're going to square root both sides to get rid of the square. E is equal to the square root of 74. So it stays the same even if you put it in a calculator. Okay, so we don't want decimal places now. So we're going to keep it in square root 74. So now we find our ratios. Sine beta, cos beta, and tan beta. They might not always put it in this order, but for now, as we're getting comfortable with it, we need to remember it, okay? So remember, sine is SOH, S-O-H, so it's opposite over hypotenuse. Cos is K, adjacent over hypotenuse, and tan is TOA. Right, let's do our substitution. Our opposite is 5, and our hypotenuse is the square root of 74. And so that's how we write it. We leave it in that form, unless it can be simplified. So cos is K, adjacent, which is 7, and our hypotenuse, which is square root of 74. Right, so let's change the color for the last one. So then tan is opposite over, so which is 5, over adjacent, which is 7, so 5 over 7. And there we go. So that's all my ratios. Right, so now we get a question like this, right? We must determine the length of AB. Can we use Pythagoras here? And what are the requirements? Do we need 2 sides at least? Do we have 2 sides? Yes or no? And unfortunately, we do not have 2 known sides to determine the third one. So we're going to have to think out of the box. We only have 1 known side. Okay. So if I can write down or identify my sides, that's my opposite. And then I need to find out where's my hypotenuse, which is 15. And then my adjacent is by side B. Right. So now I have that. Let's see what I can work with. AB is my side that I need to determine. I need SOH, K, TOA. I need to use the sides O and H. So which ratio would be appropriate for me to use? to get O and H. Is it cos, tan, or sine? And obviously it's going to be sine. So we write down what we do have. So sine, the angle is 38. Now it's not theta in this case, it's 38, it's given a value. And so it's opposite, remember, so opposite here is AB over my hypotenuse, which is 15. So now it basically becomes solving AB. So I multiply by 15 to get rid of the 15 here at the bottom. And then what I do on the right, I do on the left. So that gives me 15 sine 38 equals to AB. So you put that in your calculator. Therefore, AB equals to, now when you get your answer, write it down and round it off to 2 decimal places. And you post your answer in the comments. And there we go, that's how we do it.